Hello to everybody. Today I'm going to present you how to execute simulation, simple simulation in ns2. So in our previous video we have installed the network simulator ns2.35 in the desktop folder ns2. So I like to advise you that you should create or put your work folder in the ns2.35 folder, part of ns all-in-one 0.35. So you will enter in this ns2.35 folder, and you should create your work folder. In order to have nice systematization of the working files that you will execute and you want to simulate. So today I am going to show you some simulation about the performance of the TCP, and it will be observed the simulation script named as example1. I am going to open it. I have created for myself. I just wanted to show how to create your work environment. I have created for myself work environment named as work folder. I have created subfolder named as simulation, because in our next video, next videos we are going to observe a variety of network simulation executed in ns2. I am just creating a subfolder that is called TCP, because at the moment we are going to observe some performances of TCP. I have named the simple script is named as x1.tcl, and let's see what we are going to observe today. So first of all, you have to create a new simulator instance with the command setns. Afterwards, if you want to color the different data flows, you should put these two commands. And the first one is that we want to have one data stream colored in blue and the other data stream to be colored in red. We are putting two tags, 1 and 2. Afterwards we'll see how we are going to match them. So with the command ns color, we are creating colors. Afterwards, after we have done this, you have to open the trace files, in which in our introduction about the ns for beginners, we have said that you have to create trace files. So you said file 1, you are opening out.tr file for writing, in which you are going to this file 1. You will call it afterwards in the finish procedure. This name couldn't be different. In this script is decided to be file 1, and it will store the all trace information about all packages that are generated in the simulation scenario. So afterwards you set other win file, in which you are going to storage information about the congestion window size of TCP. So you just open a win file for writing, and you give a command in which you should do trace all, and it should do trace all, and should put all parameters in file 1. That afterwards opens the out.tr for writing. So open a num trace file. You have to open it with these two codes. You're opening file 2. We have named it as file 2. And you're opening out.num for writing. Here we're going to place the all events that will be used by the network animator 2 in order to present them with help of animation. You have to define in every simulation script, you have to define a finish procedure in which you will close the trace files and you will tell some what should be executed. So this is how we are defining finish procedure. Your simple code for a procedure. You're defining all global variables ns defined previously, file 1 and file 2 that are going to be used. You're writing ns flush trace command, you're closing the file 1, file 2, and you execute now network animator with the file out.num, and you exit. Now when we have this is the basic form of simulation script that should be done always when you're creating simulations. So you should first of all open the files in which you are going to write the tracing. So afterwards you will have to open the files in which you are going to store the information about the network animation, and to call a finish procedure. Afterwards you are creating the topology of the network. In this case we are going to have 6 nodes, so we are going to set node from starting from N0 up to N5. We are doing this with the command set something, the name of the node, and we are defining ns node. After this is done, you have to create links between the nodes, as we said previously in the introduction video about the network simulator. This is the command that is used to create a link between the nodes. We are linking the nodes as we want. In this case, we are creating Dumbel topology. After we are going to execute the network animation, you will see how it will look like. So we are creating duplex link between the node N0 and N2 with capacity of 2 megabytes and megabits, with capacity of 2 megabits with delay at the link of 10 milliseconds, and buffers that are at this link are using the drop tail mechanism. So you can use here other type of mechanism. You can change this delay and the capacity of the link. Here you can see that one duplex link, for example between the nodes N2 and N3, can be presented with help of 2 simplex links. So this is the way how to create simplex link that will define the one-way communication between N2 and N3, for example. In order to create it to be a duplex, you have to give an order to create other simplex link between N2, N3 and N2. These are the all parameters that define the links. You can give orientation of the points. For example, which link how to be oriented can be oriented down, up, right, left, right up, right down, and so on. So this is some basic. You should try it in your simulation, and you will obtain the results. You'll see that it is easy. You can set the queue size of the link between the nodes N2 and N3 up to 12 packages. You could see how it's done. It's done with the command ns queue limit N2 with N3, the nodes, and the limitation. Afterwards you can set the TCP connection. This is how it's done. We have already explained it in our introduction video. So you're setting a TCP, you're creating new agent. It has all parameters that are defined with the class agent. You're giving all or you're giving all parameters that are defined in the class TCP, and the subclass is defined to be new Reno. You can change it with the other types of protocol, for example Tahoe, Reno, SAC, and so on, that are implemented in ns2.35. So you can attach you have to attach this TCP agent to the node that should generate the TCP traffic. So in this case is denoted as NO. Afterwards you are creating sync agent that is attached to the sync node. In this case is N4. This is how it's done. You are going to set TCP, this flow that is created here. You are going to set feed 1 that will, for example, give the color of the traffic. So after you have set the color, you can define the window size of the TCP connection and the packet size. Also other parameters can be defined. If they are not defined here in this TCL script, NS, the network simulator, will be used its predefined values that are set as defaults, yes, in NS. After you have created the TCP connection, you have to create FTP connection above the TCP connection. This is done with help of these two commands: set FTP new application /FTP. You have to attach it to the TCP agent, and you can set the type of the traffic to be FTP. Creation of UDP connection is done like here. You have to create to set the UDP traffic to give them characteristic of the class agent and the subclass UDP. So you're attaching them to the node that will create this kind of traffic. In this case is N1. So you're creating them, and you create a null agent that will collect the UDP data. In this case is N5, and that will be destination of the UDP traffic. This is how it's created, and you connect them. The UDP agent with the null agent or the sync agent. You're giving the color of the traffic with this command. So you have to create a CBR over UDP connection. This is how it's done with help of these few lines. You have to type. You can set the CBR parameters here with the help of these commands. You're creating. You will giving the type name that is CBR traffic. You're going to define the packet size and the rate, how they will be generated. So or this traffic could be generated random. In this case, this parameter is set as false. This is all that you should do in order to define the traffic, and at the end you have to tell to the simulator that when to activate the traffic. So you are giving a command that NS should activate the constant bitrate traffic at 0.1 second, and at 1 second should start the FTP traffic, and at which time it should stop them. So you're giving these commands. You could also create a procedure in which you will that you are going to use it to plot the window size of the TCP this is how it's done. You're creating several variables. You're creating a global variable that is you're defining a global variable that is going to be used. You're setting time granulation 0, 1 at which you're going to take the samples. This is how you set now CVND, V and W and D as a variables, and this is how you calculate the samples at ns2.35. You're calling the procedure finish, and you're activating the script with nsrun. So now when you know everything about this script, I'm going to enter the network terminal in order to execute it. We are entering in ns2.35 folder. We are entering into the work file folder that I have created. Just work folder. In the work folder, we are entering in simulation. In TCP. So you'll define what will be best for you, how to systematically order your working folders and files. Okay, we are there in the wanted location, and I'm going to run the simulation with the command ns, the name of the TCL script, in this case x1.tcl, and I'm waiting to be executed. This is the network animator tool that we have activated in the finish procedure, if you remember. Yes. So I'm going to play it. Like you see, this is the topology that we have created, and it has the orientation that was desired. We have seen that with the CBR traffic was colored in red. Here you can adjust the step of the simulation. You can fast it up or slow it down. You can see that the links 1 and 5, the link between 1 and 5 is UDP link, and the link between nodes 0 and 4 is TCP. So you see how the traffic flows. The TCP here, you can at the node 2 you can see that we are losing some packets, and because the queue size limit was set at 20 packets. So you could see the whole simulation how is animated. We have UDP traffic colored in red. We have TCP traffic colored in blue. You're seeing the acknowledgements here and the packages that will be dropped at the queue at the node 2. So you can click at the package, on some of the packages, you will have some information about it. You can monitor it to see how. I'm just going to speed up in order to see what will happen with the time, because it's quite long simulation. It lasts for 100 seconds. So basically this is it. You can fast forward the simulation, or you can edit it. Yeah, you just saw a package that was dropped at node n2. So please try it and you'll see that it's quite easy. What I'd like it to say is, if I go at the example1 folder where I have put the example1 TCL script, I will see 3 files that we have generated and the one file is named as out.tr. If you open it, you will see the form of the file and how the information is stored. Here you have details about is it sent, at what time, between which nodes is sent the package, what kind of traffic it has, the size of the package, and some other information. Over here you can see how it looks, the TCP package, and the information about the TCP package. So these are the details that are stored. In our next videos we are going to see how we can use it in order to calculate the throughput this file and so on. The num file, you can see it. You can see the form of the num file. It's quite large, yes. So you can see the details here about the packages and that are going to be used, that are used by the network animation tool. And at last I'm going to open the Win file in order to see the information that is stored here by the procedure. This is the time and package and the value of the window size presented in packages. So we have executed a basic simulation scenario. I hope that you find it interesting and easy to use.